Any questions on that one? All right. Look like everyone's done writing. What if you wanted to solve? Bring that down some. By elimination. Say 3x minus 2y equals 2. And negative 9x plus 6y equals negative 6. Okay. So we see here it's already in standard form. So we're good for the first step. Uh-oh. Okay. Now for your second step, we just have to get these to match up. So if we have 3x minus 2y equals 2, and negative 9x plus 6y equals negative 6, we can multiply this first one by 3. Then that'll give us negative 6y and positive 6y. Okay, so we multiply each term by 3. So we have 3 times 3x minus 3 times 2y equals 3 times 2. And we have negative 9x plus 6y equals negative 6. So if we go ahead and simplify those terms up top, 3 times 3 is 9. So you have 9x. 3 times 2 is 6, so minus 6y equals 3 times 2, which is 6. You have negative 9x plus 6y equals negative 6, where we can go ahead and add them together. So if we go ahead and add those two together, 9x and negative 9x disappears. 6y, negative 6y and 6y, you add those together, you get 0. 6 plus negative 6, you add those together, you get 0. So
how did you get the equation? Wasn't it just negative 7x plus 6?
Which, for the bottom one?
Yeah. I thought you didn't touch that one.
Oh, we didn't. Yep, negative 9x plus 6y equals negative 6.
Oh, I can't be wrong.
Oh, no problem. Okay, so the left side, all the variables disappear, and on the right side, it disappears. All the variables disappeared this time, but at least we're left with a true equation. Okay, which is a little bit different from the last one. So for this one, whenever all the variables disappear and we have a true equation, then we have an infinite number of solutions, because really those two are the exact same equation. They just look a little different. Okay, so when all variables disappear, and we are left with a true, that's the key word for this one, equation. There are infinite solutions. This is a dependent system. And you know it's a dependent system because they're both the exact same graph. So your answer would be infinite solutions. Okay, and the reason why we'll kind of put underneath. Okay, so if you look at the first equation, you have 3x minus 2y equals 2. Okay, now if we look at the second equation, negative 9x plus 6y equals negative 6. What do we divide each term by negative 3? Oops. Divide each term by negative 3. So if we divide each one of these by negative 3, negative 9 divided by negative 3 is 3x. 6 divided by negative 3 is negative 2y. Negative 6 divided by negative 3 is 2. So we have the exact same equation. A lot of times it doesn't jump right out at you, but once you realize that all the variables disappeared and you have a true equation, then you know it's the same. All right, any questions on that one?
Are you saying with the infinite solutions that no matter which way you plug in,
Mm-hmm.
it's going to be exactly the same?
Yep, so if it's true for one, it's always going to be true for the other. Yep, each and every spot.
Does that just mean that the x and y are both 0?
Nope, that just means that if you plug in any x and y, you'll get 27 equals 27, or 6 equals 6, or 12 equals 12 for each and every value.
Okay. So that's the time when you might want to check yourself.
Yep, that's when you double check.
Okay.
Any other questions on this one? All right. And we'll do a quick story problem. Hope anyone's still writing. All right. Okay, so system story problems. Okay, now with story problems, the first thing you want to do is probably reread it so you kind of get an understanding of what they're asking for. So reread. Or in some cases, you can even draw a little picture or diagram. Sometimes that helps. Or drawing a picture. May help to understand exactly what you are solving for. And then you're going to choose your variables to represent your unknowns, whatever it is you're solving for. It can be X and Y, it can be A and B. Completely up to you. So choose two variables. To represent the unknowns. And translate into two equations. And then from that, you just solve it. I guess got to put that here. Okay, so let's say, for example, if we know that a show is performing locally. Okay, we know that matinee admission for 4 adults and 2 children is $374, while admission for 2 adults and 3 children is $285. Okay. What's the price of each adult ticket and each child's ticket? I swear, there'd be a circus on the moon for those costs. All right, so if you look right at the last sentence, that usually tells you what you're looking for. Okay, so we'll let C equals the price of a child's ticket. And we'll let A equals the price of an adult ticket. So if we look at each set of, I guess you could say, numbers that they give you, you have 4 adults and 2 kids, costs $374. Okay, so that means four adults and 2 kids. That's 4A plus 2C. Well, put children here just to keep everything consistent. Okay, so we know that if you get those together, it's 374. Okay. But if we have 2 adults and 3 kids, it's 285. So 2 adults and 3 children. That's 2A plus 3C equals 285. Now you don't have to use X and Y. Sometimes you can use A and C or whichever variable makes sense to you. Okay, so we have our 2 equations there. So 4A plus 2C equals 374. And we have 2A plus 3C equals 285. So if we added them together now, nothing would disappear. So we can get this equation and multiply every term by -2. That will get rid of the A. Okay, so if we multiply each term by -2, we have 4A plus 2C equals 374. -2 times 2A is -4A. -2 times 3 is -6C. And -2 times 285 is actually already worked out, and I'm not going to think about that right now, is -570. Okay, so we can go ahead and add those together now. Okay, so you have 4A and -4A, which disappears just like we planned it. Okay, so you have 2C plus -6C, which is -4C. And you have 374 plus -570, which is -196. Okay, so we have -4C equals -196. So if we divide both sides by -4, we have C equals 49. So, each child's ticket costs $49. Okay. So now we just get that and plug it into either one of our original equations and solve for an adult ticket.
You don't have to divide it.
For which one?
-4C equals -196. Like usually we would divide.
Oh, yeah, we did.
Oh.
Yep, right there. Yep, so if we plug that into either equation, so we can make it that one just because. So we have 4A plus 2C equals 374. We know C is equal to 49, so 4A plus 2 times 49 equals 374. 2 times 49 is 98. Uh-oh. So 4A plus 98 equals 374. And I'll just finish that up over here. Because if we subtract 98 from both sides, you have 4A equals 276. Divide both sides by 4. A equals $69. Okay, so each adult ticket will be $69 and each child's ticket will be $49. Like with most story problems, the hardest part is pulling the equations out of all that. So. Okay, any questions on that one? Let me straighten that up a little bit. There we go. Yes.
We have one of this for test and it asks us what the solution is, but it's 4969 or 6949?
They'll usually say adult ticket equals this, and they'll usually have it pretty separate. All right. Okay, so now I'm going to take a quick look at graphing systems of inequalities. Anyone still writing? Looks like everyone's done writing. Uh-oh. I have to actually put the steps first. Okay. Graphing a system of linear inequalities. Okay. Now the steps for this one . Okay. You're going to graph each one. Graph each inequality as an equality. Okay. That just means all your less thans and greater thans will just turn into equal signs. Less than, less than equal to, or greater than or equal to becomes equal. Okay, and let's say for 1A, if you have less than or greater than, remember your line is going to be dotted. And if you have less than or equal to, or greater than or equal to, you're going to graph with a solid line. Okay. Now, once you graph them, now you're going to pick, they should cross, and you're going to pick a test point out of each one of those sections. And plug it into the original inequality. Oh, let me clean that E up a little. Okay. Now you want to make sure to test all sections, because you could have more than one solution. Then your third step is you're going to shade in whichever test point gives you a true equation. Uh-oh, shade in. Oh, not equations, true inequalities. or just say true solutions.
So, would you be able to see their slopes before you graphed it? Like if you
With
could
those,
see.
in some of them you would, if you solve for y, you'd be able to see the slopes.
Okay. So if you could see they were parallel even before, would that mean infinite solutions? So you wouldn't even have to.
For the most part, if you show that they were parallel, like right from the beginning, then you wouldn't have to go through all that.
'Cause
But a lot of times trying to, especially if there are like fractions involved, you'll spend more time trying to solve for y than you would just doing the first couple of steps. All right, so let's say, for example, say find the solution to the system say y is greater than or equal to negative 3x plus 1, and y is greater than negative 1/2 x minus 2. Okay, so remember your first step is you're going to graph with the equal sign. Okay, so that means, and I'll put it underneath, you're going to graph y equals negative 3x plus 1. And you're going to graph y equals negative 1/2 x minus 2. Okay, so this is our x, this is our y, this is our x, this is our y. Okay, so if we let x equal 0, if x is equal to 0, that disappears, so y is equal to 1. Okay, so if we let x equal negative 1, negative 3 times negative 1 is positive 3. 3 plus 1 is 4. Okay, so we have the 2 points 0, 1, and we have negative 1, 4. Remember, we only need 2 points to graph a line. Okay, so for this one, we can let x equal 0. When x is equal to 0, that disappears, so you just have y equals negative 2. Okay, so what if we let x equal negative 2? You have negative 2 times negative 1/2. The 2's cancel out, so you end up with 1 minus 2, which is negative 1. Okay, so we have 0, negative 2, and we have negative 2, negative 1. Okay, so if anyone wants any graph paper, I can pass these around. Take one and pass it back. Okay, so we know when we graph this one, it's going to be a solid line since we're using greater than or equal to. Okay, and this one's going to be a dotted line since we're using greater than.